In this video lecture, we're going to discuss number system and data representation. Specifically, we're going to define what is digital system, what is information representation, what are the different number systems used in digital system, and what are the different operations that we could implement in number system, and how we're going to convert from one number system to another number system. And also, we're going to discuss the different coding schemes like BCD, alphanumeric code, and gray code. And also, we're going to discuss a simple detection error bit, which is the parity bit. Okay, so let's start discussing what is digital system. Let's define what is digital system. So based on our book, it takes a set of discrete information which we call input and discrete internal information which we call system state. And it generates a set of discrete information output. So basically it accepts input and together with the status of our system state, it generates an output. Input, process, output. Okay, so that's a digital system. So the input, we have a set of input acceptable by the system, by the digital system, and it generates a set of information as our output. Okay, so we have a specific input, specific output for digital. Okay, so we have two types of digital system. One is no state present. So we don't care what is the system state. Okay, so basically the output is based on the input. So which we call it combinational logic system. Most of our discussion in our course will be involving combinational logic system. Okay, so input, process, and then output. Okay, so that's no state present. And second type of digital system is state present. Now we're going to consider what is current to from our system. So we have two types of state present. We have synchronous sequential system, wherein we could take the output anytime. Okay, so there is a factor. Time is a factor to determine what will be the output for synchronous. And while for asynchronous, it will just be based on the input and the current state of the system. Okay, so that will identify the output. So again, in state present, we have two types. Synchronous, time is a factor to determine the output. While in asynchronous, the state of the system together with the input will define the output. Okay, so that's the state present. So basically, synchronous and asynchronous, an example of this is sequential circuit. This is used in storing our data. That's why we're going to consider time and state. Okay, so it will determine when to store our data. So further discussion about state present digital system will be on the 11th week. Okay, so now let's proceed in differentiating analog from digital. So let's have this example. We have two types of voltage meter rather. We have analog and we have digital voltage meter. In analog, we use a needle to determine the voltage of our circuit. Okay, so the needle moves from left to right to determine how high the voltage is or how low the voltage is. While in digital voltage meter, it will just give us an exact value. Okay, so in analog, when we read it, we estimate the value. While in digital, whatever the value written on the screen, that's the reading. That will be our voltage meter reading. Okay, So that's the two difference between one of the difference between analog and digital. One, when we read, it's estimated value, analog. Specific, exact, digital data. Okay. Now, how about this example? Left side is analog, right side is digital. So one property of analog, it is continuous. It's always changing. If you're going to move from left to right, up and down, the color will change on this spectrum. While in digital, there is a specific range wherein it will just be red, will be yellow, green, or blue. There's no abrupt change of color. There is a specific range that will determine this is the color of blue, this is the color of red. While in analog, every time you change the position, it will be equivalent to a different color since it's continuous. Another example of analog is our sine wave. Okay, if you still remember in physics, the sine wave, that's an analog. While square wave, so again, based on physics, square wave is a digital signal. Okay, so let's continue our discussion about analog versus digital. So how about how we interpret the reading? So does it change from one person to another person when we read the device? For analog, definitely yes, because every person that going to read this analog clock will give us an estimated value. So therefore, there are different ways in representing estimated value. For example, it's about 2, 150, 154. So there's no exact value. While in digital clock, since we have an exact value, any person that going to read the device, the clock, will give us the same reading. Okay, so everyone will have the same reading in digital, while for analog, it's ambiguous. It could change from one person to another person. Okay, and one advantage of digital versus analog is we could implement easily detection error and correction error algorithm. And also, we could send digital signal in a bad medium, okay, which has lots of noise, okay, that could interfere with our signal, with our data, okay. So we could easily correct those issues, those error encountered by a signal when it is received by the receiver. So it is easier to get the original data using digital compared with analog, even though it has lots of noise when we transfer it. Okay, so again, easy to implement detection and correction error when using digital compared with analog. Okay, so next video on our next video lecture, we're going to discuss number system. So thank you for listening. See you on the next video lecture.